So we're going to pick up right where we left off from last week. Recall that we'll be running evals on a React agent with access to Tavily Web Search, Wikipedia Search, and current Datetime. It's powered by LangGraph and uses Claude 3.7 Sonnet for reasoning, and has access to Tavily Web Search. Today we'll be running three types of evals. Agent function calling, does the agent select the right tools? Agent path convergence, does it follow the optimal reasoning path? Q&A retrieval, can it reliably provide the correct answers? Let's jump right in. Okay, so here's where the real magic happens. Now we're going to start our evals. So I start by first downloading all the span data from the Phoenix server. And one of the things that I like about Phoenix is once you download all of these spans, you can actually convert it into a pandas data frame for data manipulation. Right, and as you can see here, a little bit of manipulation is required in order to get the column names that the agent function calling prompt template expects in this case. Okay, so the first eval that we're actually going to be running is an agent function calling. Okay? So the prompt template expects question, tool call, and tool definitions. So we're going to be utilizing a built-in LLM as a judge capability via the LLM classify, okay? And here's the prompt that will be used in order to evaluate whether the response is either correct or incorrect, right? And it's a binary value. So typically this is considered a best practice, right? For labels when using LLM as a judge, as they often get confused by numerical values or ranges, okay? All right, so here I have the script set up, right, to start running the evaluations. And notice how I'm using Anthropic, right? So the same model, essentially, Claude 3.7 Sonnet, setting temperature to 0 and max tokens to 2000. Okay, so let's check this out. Let's run it. Okay, and here is the labels, right, from the evaluation. So you can see that out of 9 examples, 2 were incorrect. Okay, so let's take a closer look at what was labeled correctly and what was labeled incorrectly in this case. Okay, so here I have one of the explanations, right? Okay, so this is for the weather question. You know, user asks about weather in Queens. Okay, it returns the Tavily Web Search results. Fine. Note that it's actually for Queens Village. That's fine. It's close enough. I didn't actually specify. I would probably rerun it. The tool call included the correct parameters extracted from the question, searching for weather in Queens, New York, for the specified date. No outside information not present in the question, yada, yada, yada. The web search tool is appropriate, labeled correct, okay, for current weather information. Awesome. All right, and here I'm just getting, again, like the tool call. I'm just kind of, you know, just seeing, like, is it actually getting it from the original data set? Yes. Cool. All right, so here I wanted to look at like one of the incorrect examples, right? To just, you know, take a peek at what it's actually doing. So the question was about a large language model evaluation methods. The tool call was Wikipedia, which is an interesting choice, right? It's appropriate for seeking information about technical topics. However, when examining the content returned by the query, notice that it contains information, right, about what language LLMs are, LLMs in general, foundational models, right? It doesn't actually contain anything about evaluation methods in this case, okay? It appears to have returned general information about LLMs rather than the specific methods to evaluate them, which is why this was labeled incorrectly, okay? So here's another really cool feature about Phoenix, right? To log the annotations and write them back to the platform. Okay, so now I'm gonna go back. Okay, so over here under annotations, you can actually see some of the annotations. So if I click here, right, Tavily Web Search results, LLM evaluation benchmarks, okay. right? The annotation is correct. Okay, perfect. Hey, I'm an AI product career coach who's helped dozens of clients land AI PM roles at FANGs and Fortune 500s by designing their careers with AI, even in today's job market. Look, every PM needs to become an AI PM. PM job openings are up 54% from 2023 lows. AI PMs earn a 35% salary premium compared to traditional PMs, according to an Amazon survey. AI product management's absolutely exploding right now. DM me. It's open enrollment. Hope you're ready. Okay, so now we're going to start our evals on agent path convergence. So recall, agent path convergence is how efficiently the agent executes multiple steps in a path to get an answer or a resolution. Okay, so it's actually recommended when evaluating agent path convergence to use a set of similar queries, right? So they're all basically asking the same thing, but there are variations in the way that the questions are worded. So for this, I actually put together a synthetic data set about Christopher Nolan's place of birth, right? The famous director. So notice, like, you can see them clearly down here. What is the birthplace of Christopher Nolan? Where was Christopher Nolan born? In which city was Christopher Nolan born, etc. Right? And I actually uploaded the data set to Phoenix. All right, you can see that here under data sets, right? Okay, so for the purpose of this, we're defining path length as the sum of human messages, system messages, tool messages, and AI messages. For AI messages, it's comprised of reasoning steps and action steps. Okay, so let's head into the script here. Note that I did use a custom script in order to compute convergence for LangGraph. All right, so here's what that script looks like. And then I used Arize Phoenix's experiment feature, which is another really cool feature. Okay. So after logging the results back to Arize Phoenix, right, and then getting the path lengths, I then just did like a quick average, right? And so the average of 10 runs was about 8 steps. Okay, so let's look at some of the examples here. Can you tell me where Christopher Nolan was born? Path length of 10, right? Human messages, 4 tool messages, and then 5 AI messages with the reasoning step. Okay, so here I actually just improved the prompt a little bit, right? Based on the average convergence from the last experiment. I was just curious in seeing like if I added some examples, right? And whether I provided more detail, like, so this search process was not included before. The good and bad examples, right, were not included before. I basically included some methods from the best practices of prompting, right? Clear and actionable steps, good and bad examples, just to see, right, curious what would happen. All right, so here we reinitialize the agent with the new prompt. Okay, and then we essentially just rerun the experiment. And just from prompting alone, right, I reduced it by about a step, okay? So, you know, in this example, right, this was the one that we looked at before. Can you tell me where Christopher Nolan was born? It was previously 10 steps and now it's 6 steps, right? And as you can see, all the examples are actually about 2 to 4 steps less. All right, so now we have our last eval for the video, and this is on question and answer on retrieved data. Okay, so again, right, wanted to specifically evaluate the Wikipedia tool. So generated a synthetic data set of a bunch of questions, right, that are historical in nature, about like popular TV show or, you know, actors or characters, capital of France, just like some, pop quiz type questions, trivia questions. Okay, so here we have our data set. Again, it's manipulated a bit in order to match the expected prompt template. Okay, so then we run the evals, right? 10 questions. So it's predicting, in this case, right, the LLM as a judge, right? The anthropic model's predicting that everything's correct. But here, it's actually, it's actually repeating the explanation in the label. So probably something that I need to evaluate, no pun intended here, and see why that's occurring. Okay, but here I took like a closer look into like some of the examples, and they were actually all correct, right, when I looked at them. But again, it's not providing a thorough explanation, which is worth looking into in this case. All right, so that wraps up our evaluation series. Again, we covered agent path convergence, we covered Q&A classification, and then we covered agent function calling, right? So thank you so much, and I'll see you in the next video.